Okay, so let's look at the gradient of a curve. Let's look at the gradient of a curve. So if this is our curve here, we'll realize that the curve, unlike a straight line, is always changing the direction of tilt. So at every given point, it's sort of changing the direction that it was pointing towards, right? So when we deal with curves, when we're looking for gradient, we look for gradient of the curve at a particular point because the value for gradient is different for every point. So we look for gradient at a particular point. Now we have a simple 4-step process to find or to calculate the gradient of a curve. A simple 4-step process. So the first step is locate the desired point. Now this comes with the question. Whenever you're asked to find the gradient of a curve, you're told to find it at a particular point. They might say at x is equal to -1, at x is equal to 2, find the gradient at x is equal to 3, at x is equal to 4, find the gradient at x is equal to 5. Wherever they tell you to find the gradient, that's the desired point. You need to locate that point on the curve. First, that's your first step. Identify for which point on the curve am I looking for gradient. The next thing you need to do is to draw a tangent to the curve at that point. You need to draw a tangent. Now, a tangent is a line that is external. It's outside the curve. So it's an external line that makes contact with the curve at the desired point. So the line is going to come from a point outside the curve, make contact with the curve, and then continue, right? And move past that point. And so that's a tangent. We'll see how that looks in practice. When you've drawn your tangent, you pick any 2 points on the tangent itself. So the 2 points are picked on the tangent that you have drawn, right? For each point, identify the x value and the y value, the x value and the y value. So those 2 points will become your x1, y1, and the other point will become the x2 and the y2. Once you have all that data, you can now calculate your gradient using the formula y2 minus y1 over x2 minus x1. So those are the steps that we need to follow. So now, this is an example. For the curve y is equal to 3x minus x squared, find the gradient at x is equal to 2 and find the gradient at x is equal to 0. So we're going to start off with the first one. Now, if you look at our points, the first thing is locate the desired point. We're told to find the gradient at x is equal to 2, so let's look at where x is 2. So on the x-axis, our 2 is here. So the point that is in line with that 2 is our desired point. So this is the point that we are looking at, aren't we? So for this point, this is where we draw our tangent. So we can go ahead and draw a tangent at that point. Our tangent is going to be a straight line. You use a ruler. That's going to proceed. It's outside the curve. It's going to come. It's going to make contact with the curve and move past that point like that. So that's our tangent. Right? Once we've drawn our tangent, we've done the first 2 points, right? Locate the desired point, draw a tangent to the curve at that point. You then pick any 2 points on the tangent, right? Itself, the tangent, right? This is our tangent. We pick any 2 points on that tangent. So I'm going to use red. So I can pick the first point is this one. And then I can pick the second point is that one. So the 2 points I marked with red. So for the first point, my x value, let me just use a different color there, yellow maybe. Our x value is going to be 3. So my x value is 3. And then my y value is going to be 1. So this is going to be the point 3, 1. For the other point here, my x value is 4.1, right? For that point there, the x value is 4.1. And then the y value is 0, okay? So I have my 2 points, 3.1 and 4.1 and 0. So I can take those points and write them here. What's the first point? The first point is 3.1. The other one is 4.1 and 0. So this will be my x1, y1, and this will be my x2, y2. I can now calculate my gradient using my formula. y2 minus y1 all over x2 minus x1. What's my y2? 0. My y1, 1. What's my x2? 4.1. What's my x1? Is 3. So I get a minus 1 divided by 1.1. So that's going to give us maybe a minus 0.9 something as your final answer there for your gradient. So that's the full process of finding your gradient. So now let's answer the second question. The second question wants us to find the gradient at x is equal to 0. So they want us to find the gradient at x is equal to 0. So I'm just going to erase part of this just to make it simpler for us to visualize. Okay, so I am erasing the first part. Okay, so now we're looking for our gradient at x is equal to 0. Now if we take a look, we realize this is where our 0 is, and that's right on the curve. So we need to draw our tangent, which is going to come, make contact with that point, but pass the curve without entering or going inside the curve. The tangent, as you can see, stays outside the curve. It never cuts into the curve. The only place it makes contact with the curve is at the desired point. So that's our tangent. Once we have our tangent, we can identify 2 points on the tangent, right? Using maybe yellow. The first point could be this one. This point is on the tangent, right? It may be on the curve, but it's also on the tangent. And its coordinates are 0 and 0. We can pick another point, right? This point here. This is a minus 1 and minus 2.9. So that's a minus 1 and a minus 2.9, right? That's the y value. So we can plot that, we can put that down there, right? We can have the point 0, 0 and the point minus 1 and minus 2.9. This is our x1, y1. That's our x2, y2. Our gradient is equal to y2 minus y1 over x2 minus x1. That's going to give us minus 2.9 minus 0 over minus 1 minus 0, right? So this is going to give us minus 2.9 over minus 1. Minus is cancelled, 2.9 over 1. We get our gradient of 2.9. So that's the simple process of calculating the gradient of a curve.